This video covers basic chart stacked bar chart. The structure of this video is as follows: visual code walkthrough, JavaScript code build, and the summary. Alright, let's get started. Visual code walkthrough. We will cover the D3.js.org website stacked bar chart example. What is crucial to understand about this chart is that the data is a two-dimensional array where we have data on 51 states, and for each state we have data on 7 age groups. So first we have to create 51 JavaScript objects, which is one for each state. Each of the state JavaScript objects gets bound to an SVG group element. Then for each state, we have to create 7 JavaScript objects for each age group population breakdown. The 7 JavaScript objects are aggregated into an array so that we can later use the D3 pattern of passing an array of JavaScript objects to the D3.data functionality. Each of these age group JavaScript objects gets bound to an SVG rectangle inside of their respective SVG group element for the state. Once we have that understood, the chart is created using two technical ideas which we go into more detail during the visual code walkthrough. We will save the data from the example into a file called data.csv. This file is the one that will be loaded asynchronously using the d3.csv request functionality. The document starts with the doc type, meta character set, and CSS styling. This is the standard HTML doc type, meta character set definition, and CSS styling for the D3 data visualization we are making. Next, we go into the JavaScript sections of the document. First, we load the D3.js JavaScript library from the web. This uses the D3 code hosted on the D3.js.org website. Next, we go into the D3 code that will create the stacked bar chart. The D3 margin convention sets up the SVG container size as well as defines the inner drawing space. The SVG container will be 500 pixels tall by 960 pixels wide. Next, we have an ordinal scaling function for the x-axis data. This code creates an ordinal scaling function where the range goes from 0 to the width of the inner drawing space. This ordinal scaling function is using the range round bands to set the bands. Also, the point 1 is the padding added to offset the bands from the edge of the interval. Next, we have a scale linear function for the y-axis data. This code will create a scaling function where the range goes from the height of the inner drawing space to 0. The height and the number 0 are reversed so that numbers passed into the scaling function will be converted to numbers that act as if the SVG coordinate space had been inverted along the y-axis. The range round sets the scales interpolator to D3.interpolate round, which makes values outputted by the scale to be exact integers. Next, we set up an ordinal scaling function for the colors that are going to be used for the different age ranges. The range is a list of 7 HTML colors. Note that the domain is not yet set. Next, we create the x-axis function. We pass in the x-scale function we created earlier and then give the axis an orientation of bottom. Then we create the y-axis the same way. We pass in the y-scaling function we created earlier and give the axis an orientation of left. We also give the numbers a formatting using the d3.formatting function. This type of formatting is called SI prefix formatting. The next code creates the SVG container and the inner drawing space. The next code is where the D3 does the asynchronous call to the server to get the data and then builds the chart. In this case, the callback function is an anonymous function. Note, this example uses D3.csv for comma-separated values, not D3.tsv for tab-separated values. Let's go through the callback function section by section. First, we have code that looks at the first data element, gets the keys, and then defines the domain of the ordinal color scale based on those keys. This is constructed in a series of steps. First, data0 returns the first JavaScript object. Then, the d3.keys functionality looks at each key value pair in the object and returns only the keys. This list of keys is returned as an array. Next, the JavaScript array filter method is used to apply an anonymous function to each element of this keys array. The anonymous function returns the element as long as it is not equal to the string state. Lastly, this array of keys, which represents all of the different types of age groups, is used to set the domain of the color ordinal scale function. This ensures that when an age group in the domain is used, it will be colored the same way everywhere on the chart. Next, this code iterates through the array of JavaScript objects and defines the coordinates, which will later be used to construct the rectangles. For each JavaScript object, this code does two main things. The first main thing is it adds a new key value pair to the object. This new key value pair has as its key name the word ages and has as its value a JavaScript object that contains three keys inside of it: the name of the age group, a Y0, and Y1. Y0 is the total sum of the population below that age group. Y1 is the population at that specific age group plus Y0. So for the under 5 years age group, Y0 will be 0 and Y1 will be the population of the under 5 years age group. For the 5 to 13 years age group, Y0 will be the total sum of the population below the 5 to 13 years age group. Y1 will be the total sum of the population below the 5 to 13 years age group plus the population of the 5 to 13 years age group. This goes on for all the age groups. The second main thing this code does is, once it's defined the ages key value pair, is to figure out what the total population for the state is. It does this by looking at the last element of the ages key value pair object and getting the Y1. The Y1, as we just defined it, is the sum of all the age groups below that age group plus the population of that age group. So the last Y1 of the associative array will be the oldest age group, which means it'll tell you the full population. We will explore this further in the JavaScript console. Next, using the JavaScript array sorting method, this code sorts the JavaScript data objects according to their total population. The JavaScript array sorts the numbers as follows. If the return value is less than 0, then sort A to a lower index than B. If the return value is 0, then leave A and B unchanged. If the return value is greater than 0, then sort B to a lower index than A, which means in this example that this will sort all the elements in the data array such that it goes from the largest state population to the smallest. This is the first of two reasons why the earlier for each array code broke out the total population into its own separate key value pair. Next, we set the domain for the x ordinal scale function. This sets the domain of x as the list of all the states found in the data set. Note that the data has already been sorted, so the domain will be sorted as well. Next, we set the domain for the y-scale function. The domain of the y-scale function is a continuous linear function, so the domain will be defined as going from 0 to the max population of all the states in the data. This is the second of two reasons why the earlier for each array code broke out the total population into its own separate key value pair. Next, we call the D3.access operator for the x-axis. This creates the full x-axis. Then we create the y-axis and a y-axis text label. This creates the full y-axis. Then we use the D3 pattern to bind JavaScript objects to SVG group elements. Each JavaScript object represents one state plus Washington, D.C. So 51 SVG group elements will be created and each one will have bound to it the data for each state. Note that each SVG group element is transform translated based on the x ordinal function for each specific state. This ensures that when the rectangles for each age group are constructed, they are constructed in the right place on the graph. This collection of SVG group elements is then assigned to a variable named state. For each state SVG group element, we have to construct the stacked bars according to the different population sizes in the different age groups. This code uses the D3 pattern to bind the age group data to SVG rectangles for each of the age group segments found in each state. For each state and the state variable, we are going to do the following. First, select all the rectangles. Then using the data bound to each state, we look at the ages key and get the array of objects that is the value of that key. This array of 7 different age groups and their data is what gets passed to the data function. The data function creates 7 placeholder elements in total since there are 7 age groups. The enter selection is selected. Then the append is called, which merges the placeholder elements and the SVG rectangle elements. Then the attributes of each rectangle are defined for each of the 7 age group rectangles. Then the attributes of each rectangle are defined for each of the 7 age group rectangles. The width is based on the x ordinal scale function range band. The width is the same across all 7 age groups for each of the 51 states. The y-coordinate is calculated from getting the y1 of each age group in each state and then putting it through the y linear scaling function. If you recall that the y1 is the total population up to and including the age group, it makes sense, since the SVG rectangles are defined from the top left corner. Next, the height of the rectangle is calculated as the difference between y0 of the age group passed through the y linear scaling function minus the y1 of the age group passed through the y linear scaling function. If you are wondering why they are backwards, it is because the y scaling function is backwards as well. That is, the y scaling function range goes from height to 0 in order to have the points scaled through the function behave as if the SVG y-axis was inverted. Finally, the fill of the rectangle is chosen based on the color ordinal scale we defined earlier. Next, the legend for the chart is constructed. First, SVG group elements are added based on the D3 pattern. SVG group elements are based on the data of the age group names. The color ordinal scale domain age group names array is sliced and reversed so that the array has the oldest name of an age group 65 years and over come first. The SVG group elements are transform translated according to the index element so that they line up from top to bottom on top of each other. This ensures that the sliced up and reversed array of names has the oldest age group on top going to the youngest age group on the bottom. Then rectangles are added to the legend SVG group elements based on being 18 units away from the right-hand side of the inner drawing space. The color of the rectangle is dictated by the data that was bound to each legend SVG group element. Because the domain has already been set for the color ordinal scaling function, it will match up exactly to the bars that were constructed for the group bar chart. Lastly, the age group name is added to each legend SVG group element. The text of each legend is set according to the data bound to each of the legend SVG group elements. And that is the end of the callback function and the end of the D3.csv function. When this is done, the graph will have been fully generated. Let's now build this part by part in JavaScript. JavaScript code build. Because in the example the building of the chart happens inside of the callback function, we will use a more simple anonymous function in the JavaScript console. Alright, to the JavaScript console. After downloading the data to a data.csv file, starting the Python simple HTTP server, and making sure D3 is loaded, we open the Chrome Developer Tools and go step by step building the visualization. We start by defining the callback error and callback data variables, which will be used to house the data we get back from the D3.csv function. The first step from the example is defining the margins and the width and height of the inner drawing space. Next, define the x ordinal scale function and its range around bands. Next, define the y linear scale function and its range. Remember to pay attention to the fact that the range has height first and then 0. Also pay attention to the fact that we are using range round to make sure the scaled numbers returned are integers. Next, define the color ordinal scale function and its range, which will be used to color the different age groups. Next, define the x-axis function and provide it with a scale and orientation. Next, define the y-axis function and provide it with a scale and orientation and tick marking. Next, define the SVG container and the inner drawing space. Next is where we are going to differ a bit from the code of the example. Instead of defining an anonymous callback function that does all the generating of the chart in one go, we will define a callback function that assigns the data and error to variables. We'll then use the callback error and callback data variables to build the grouped bar chart. Inside of the callback function, we have a console log of an array of the callback error and callback data.length so we can see what is in each one of them. We can see that the callback error is null and that the length of the callback data array is 51 elements, which represents the 50 US states and the city of Washington, D.C. Once we have the data, we extract the age group names from the callback data array and assign them to the domain of the color ordinal scale function. You can see all of the age group names. Before we do the array for each iterator, let's take another look at the first element. When we expand the objects, you can see that it has all the age groups and their respective values as well as the state. Next, use the array for each iterator to go through the 51 element array, and for each state element create 2 new key value pairs inside. The first key is the string ages, and the value of this key is an array of JavaScript objects. The second key is the string total, and the value of this key is the total population for this state. The first key's value is an array of objects where each of these new objects has 3 keys: the string name, the string y0, and the string y1. The key name has as its value the age group name. The key y0 has as its value the sum of the population of all the age groups beneath this one. The key y1 has as its value the sum y0 plus the population of this particular age group. These 2 levels of JavaScript objects defined inside of JavaScript objects is necessary to produce the stacked bar charts. The first level pertains to the states, and the second level pertains to the stacked bars of each state. Now we look at the first element again. Note that this state is AL, which stands for Alabama. This time you can see that 2 new key value pairs have been added. We look at the first object and the key value pair of ages and the array. You can see that the name of the age group, which is under 5 years, has Y0 as 0 and Y1 as 310,504. If we look slightly up, we see in the original key value pairs of the object that the size of the population of the under 5 years is 310,504, which is the same as Y1. The Y0 and Y1 for this object make sense. There are 0 people under the under 5 years age group, so Y0 is 0. Y0 plus 310,504, which is the population of the under 5 years age group, is 310,504, so Y1 makes sense. Next, let's look at the second object and the key value pair of ages. You can see that the name of the age group is 5 to 13 years, that Y0 is 310,504, and that Y1 is 862,843. Y0 is 310,504 because this is the total sum of all the age groups below 5 to 13 years, which in this case is only the under 5 years age group. Y1 is 862,843 because it is the Y0 figure plus the 552,339 figure from the 5 to 13 years key value pair in the original JavaScript object. This continues for the rest of the 7 age group specific objects. If we look at the last object, we see that the age group it represents is 65 years and over. The Y1 here is the total population for this age group and all the age groups below, which if we look at the first level of key value pairs also equals the new key value pair that was added, which is the key total and the value of 4,661,900. So this value makes sense as well. Next, sort the callback data variable so that the states with the largest populations come first and then decline in order. If we check the first element of the callback data array, we can see that CA, which stands for California, is now the first state. This is because CA has the largest population of all the states in the US for this dataset. Next, define the domain of the X ordinal scale function and then check to see what the domain is. The domain of the X ordinal scale function is the 2-letter abbreviation of each American state present in the data, sorted by the order of descending population. Next, define the domain for the y linear scale function and then check to see what the domain is. The y linear scale domain goes from 0 to 36,756,666. Next, the x-axis is created. If we click into the SVG group element for the inner drawing space, you can see the SVG group element with the class x-axis. Next, the y-axis is created with the text label. Next, create the SVG group elements which the JavaScript objects which represent each state will be bound to. Note that each SVG group element is transform translated to the corresponding place in the chart based on the x-ordinal scale function. Next, for each of the SVG group elements just created, let's create the rectangles based on the age group breakdown and population for each age group. The rectangles now appear. Remember that rectangles are constructed from the top leftmost point. If we go into the first SVG group element, which represents California, and we hover over each rectangle, we can see how each rectangle is built on top of each other. Next, the legend for the chart is created. First, the SVG group elements for the legend are created based on the data of the age group names from the color ordinal scale domain. Next, create the rectangles that are colored based on the age group. Finally, create the text that goes along with each legend and its colored rectangle. And there we go, we have the stacked bar chart. Let's close the Chrome Developer Tools to get a better look. You can see the full picture. And with that, we built the basic chart stacked bar chart. What is crucial to understand about this chart is that the data is a two-dimensional array where we have data on 51 states, and for each state we have data on 7 age groups. So first we have to create 51 JavaScript objects, which is one for each state. Each of the state JavaScript objects gets bound to an SVG group element. Then for each state, we have to create 7 JavaScript objects for each age group population breakdown. The 7 JavaScript objects are aggregated into an array so that we can later use the D3 pattern of passing an array of JavaScript objects to the D3.data functionality. Each of these age group JavaScript objects gets bound to an SVG rectangle inside of their respective SVG group elements for the state. Finally, the rectangles are then colored and positioned using X and Y coordinates as well as the height based on their population. The summary. This video provided a visual code walkthrough, a JavaScript code build, and the summary.